In this video, we're going to talk about isosceles triangles. Just for a recap, a review, isosceles triangles have at least two congruent sides. Okay, each side is congruent right there. And the angles opposite those congruent sides are also congruent. The converse is also true. The sides opposite the congruent angles are also congruent. So regardless of which one we're given, if we're given that an isosceles triangle with two congruent sides, then we know that the opposite angles are congruent. Or if we're given an isosceles triangle with two congruent angles, then we can also say that the sides are congruent. This is called a corollary, okay? A corollary is a naturally flowing statement that comes from a theorem or postulate. So we can prove it if we need to, but it's not absolutely necessary. The bisector of a vertical angle of an isosceles triangle is the perpendicular bisector of the base. Okay, and we know this, again, this is a corollary, okay, meaning that we know this just from our isosceles triangle theorem, right? Let me get all this stuff up there. We know that an angle bisector, right, is the bisector of the vertex angle makes the angle in half. So you would make two triangles, right? And if this was an isosceles triangle, okay, then this side and this side are still going to be equal. And according to reflexive property, we know that this side is equal to itself, right? Right here. So we have this side, and this angle. Side, angle, side proves that these two triangles are congruent. Okay, so if we know that these triangles are congruent, we also know that the other angles are congruent. So this has to be a 90-degree angle, which means that it's a perpendicular bisector. Some terms right here are, this is the vertex angle, all right? Just, it's the vertex, right? It's the top of the triangle. So we call it the vertex angle. This is a leg, okay? And this is a leg. We call the legs are the two sides that are congruent, okay? This is the height of the triangle. This is the base. And these are the base angles, okay? We call those the base angles. Okay, when you use a shortcut, okay, like side, 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 angle, angle, side, angle, side, or angle, side, angle, to show that true triangles are congruent, that means all the corresponding parts are congruent. So if a triangle is congruent by ASA, for instance, so you know that two triangles are congruent because they have an angle aside and an angle congruent, then all of the other corresponding parts are also congruent, okay? So like for this one, we know because of angle, side, angle, right? Angle, side, angle. We know the triangle ABC is congruent to triangle FGE. So we know that EG right here is congruent to CB. So what would AC be congruent to? Okay, so if we have AC, right, A here, see the two lines that are showing this angle is congruent? That means that you're looking for the other one that is congruent. So A is congruent to F, right? And we went from A to C where there is no, we don't know the congruence right here. We don't know the congruence right here. So AC would be congruent to FE, okay? Corresponding parts of congruent triangles are congruent. I know that's a lot of words here, right? Corresponding parts of congruent triangles are congruent. Okay, that's what we've just been talking, right? That the corresponding parts, the parts that match up of a congruent triangle, those parts are also congruent, even if we weren't specifically giving them. Okay? What we like to use instead of saying this whole long word is CPCTC. And this is a huge this is a huge postulate that we're going to use here, okay? We're going to use this a lot. Once you know CP/CTC, you will use it a lot in proofs. So it's really important that you understand it, okay? So what it says is that if you can prove congruence using a shortcut, then you know that the remaining corresponding parts, okay, all of the corresponding parts are congruent, okay? You can only use CP/CTC in a proof after you have proved congruence, okay? So we first have to prove that a triangle is congruent, and then after that, then we can prove that other sides and angles that we weren't given are congruent. So on this one, okay, if we were given triangle BFG is congruent to triangle QNL by SAS, right? Side, angle, side, side, angle, side. Determine if each statement is true according to CP/CTC. So we've already proved here, right? BFG is congruent to QNL, okay? So we want to see here, we want to say, this one says that angle F is congruent to angle L, okay? Now, if we looked at that, right, and imagine that we just flipped this triangle up so that this was at the top, right? F is not in the same spot as L, so this one is not true, okay? We can't use CP/CTC to prove that. Now we're going to say that that angle F is congruent to angle G. Okay, that's also not true because CP/CTC is talking about two different triangles. We can't compare angles within one triangle using CP/CTC. Now this one says that angle B is congruent to angle N. Okay, again, those are not in the same spot, so we can't say that those are true, okay? Some true statements then that we could come up with, all right? Well, we know that BG and LQ, right, are congruent because we're given that. We know GF and LN are congruent, and we know that angle G and angle L are congruent. But we also know that angle B is congruent to angle Q, okay, and we also now know that angle F is congruent to angle N, okay, and then we also know that segment BF is congruent to segment QN. Here we're going to determine whether these triangles are isosceles according to the given side lengths, okay, and remember, an isosceles triangle has to have two side lengths that are the same. So for A, 12, 8, and 7, it's not an isosceles triangle. Here we have one that's 11, 11, 15. So yes, that one is, right? Because it has two sides that are 11. Here we have 3, 1, 3. So that one is yes because it has these two 3s that are in common. So so A is no, B and C are yes. Okay, if you're given that A, B, C is isosceles, okay, and here we're given that AC is 42 and BC is 42 and angle A is 71 degrees. Which sides are the legs? Okay, remember the legs are the two sides that are congruent. So the legs here would be AC and BC, okay? The side that's the base, okay, is the line that's not the legs, okay? So AC and BC were the legs, so AB is going to be the base, okay? Angle A is an angle that's on the base, right? A and B are both angles that are on the base, so angle A is called a base angle, okay? And then angle C up here at the top, okay, it's at the top of the triangle, it's between the two legs, okay? It's called the vertex angle. So again, same thing right here, except now we're given PQR and we're just given these little hash marks. And again, remember, these hash marks do not say that the lines are parallel, and they do not say that, they do not mark a midpoint. These lines are saying that QR is congruent to PR, okay? So which sides are the legs? Now, what we talked about, the legs are the congruent sides. So that would be QR and PR. Okay. The side that's the base is the one that's not the legs. So that would be side QP. Angle Q, okay, it's the angle Q and angle P. Those are the angles that are on the base. So angle Q is the base angle. And then angle R is the one in between the two sides, and it's the top of the triangle. So it's the vertex angle. Okay, so even if this triangle, and that's the thing, even if this triangle is on its side, okay, that's why it's always important to know where your, like, there we go. Oh, I don't know why it keeps doing that. Okay, why it's important that the vertex angle is between the two congruent legs, okay? Because you don't want to just say that it's the top one, because if you were looking at the triangle like this, you might want to think that Q is the vertex angle. But remember, the vertex angle is the one that is in between the two congruent legs, okay? So that's angle R right there. Okay, on this one, we want to find X and we want to find Z. Okay, so remember what we know about isosceles triangles, okay? An isosceles triangle, if the two congruent sides, okay, right here, AB and AC, we know that the opposite sides are congruent, okay? So angle X, okay, is opposite one of those congruent sides, and so is angle B. Okay, B and C are base angles, and they're always going to be the same. So if B is 32 degrees, then we know that X is also 32 degrees. Okay, now in order to get Z, the vertex angle, right, we already found that this is 32 and 32. Well, remember, triangle sum theorem says that a triangle has to add up to 180. So we're going to add these two together, 32 and 32. We're going to get 64. And then we're going to take 64 and we're going to subtract it from 180. And that's going to give us 116 degrees. So angle Z is 116 degrees. And just a quick note here, okay, on you know how we always talk about not looking at the picture, right? That because if you were looking at this picture, right, it kind of looks that all three of these angles are the same. That's why it's really important to use your algebra and not go off the picture, because the pictures aren't drawn to scale all the time, right? Because 116 degrees is actually going to be an obtuse angle, which doesn't really look that way. Okay, so again, this is why it's really important to use your algebra and not go off the picture. Okay, here we want to find the value of X and then find the value of AC after that. Okay, so here, all right, just like on our, like what we know here, we have two congruent angles. Okay, so we know that these two sides then are congruent, right? We know that this is isosceles triangle. So we know that this angle also is 32 degrees. Okay, since we know that, we know this whole triangle has to add up to 180 degrees. So we're going to add 32 and 32, which is 64 plus 8x, and that's going to equal 180. So we're going to subtract 64 from each side, okay, and that's going to give us 116. And then we're going to divide by 8. And x is going to equal 14.5. Okay, so that's the first part, x. Now we want to find AC. So to find AC, it's 2 times x. Okay, so we're going to take 2 times 14.5, and that's going to give us 29. On this one, on the next one right here, okay, find the measure of angle LMN. Okay, these two are isosceles, so we know that this angle is equal to this angle. So we know this angle is also 2x. So here we know 2x plus 2x plus 5x equals 180. 2x plus 2x plus 5x is 9x. When we divide by 9, x is going to equal 20. So to find angle LMN, we're going to take 5 times 20, which is 100 degrees. So, oh, we want to find all the measures. Sorry, I thought that said angle element. It said triangle element. Okay, so angle M then, okay, angle M equals 100 degrees. Angle N is 2x, so it's 2 times 20, which is 40. So we also know that angle L is also 40. And if we check our work here, right, 100 plus 40 plus 40 is 180. Okay, on this last one, we're going to do a proof, okay? Remember when you're doing your proofs, you're just looking at the statements given and you're asking, how is this true? Okay, how do I know that this is true? So here we're given that SP is congruent to PQ right here, and we're given that SR is congruent to RQ. And we want to prove that angle S is congruent to angle Q, okay? Now here, we're given this side is congruent and this side is congruent. We're given this side is congruent, these two sides are congruent, and these two sides are congruent. We also know that this side is congruent right here. PR is congruent to PR, and we know that because of the reflexive property, okay? So now, because we know that these sides are all congruent, we can say that triangle SPR is congruent to triangle QPR according to side, side, side. And since we know that these two triangles are congruent, we can prove that angle S is congruent to angle Q by CPC/TC, corresponding parts of congruent triangles. And that is the end of isosceles triangles and CPC/TC.